So, quickly, my name is Claudio Contin. I'm a penetration tester at OWASP Information Security. Well, as part of our job, we do also research, and I have a long history as a web developer, mainly Java, PHP, and long history of Ruby on Rails. So the aim of this talk is to present this interesting attack, which is not a new attack, it's not. So it relies on few factors, so which I will quickly explain in order to understand actually the attack at the end. So this attack relies on unfiltered JSONP callback, relies on service worker, on fetch event, and an existing cross-site scripting vulnerability on a website. There will be a short demo after the explanation of the three and some consideration at the end. So quick explanation of what JSONP is. So a standard AJAX request, usually created with a XML HTTP request, and you specify your URL, which of course needs to point to your same website unless the remote website you're calling specify some course headers. So a way to kind of allow cross-domain communication without messing with course header is using JSONP. So when you want to call a JSONP endpoint, you dynamically create a script element on the current DOM, and you set the source to be the outside world URL in this example, and you specify a callback URL. You put this in your DOM again, and the response will typically look like something like this. So my callback will be referred to the same value you specify in the original callback value, and the data will be part of the function call. So it is not AJAX in the typical AJAX sense. So as I say, you include the tag dynamically on your DOM, which means same origin policy does not apply. And when you receive the response from a JSONP endpoint, of course, the definition of the function you specify in your callback parameter needs to exist. So what service workers are? They are still on experimental technology. They've been invented by Google a few years ago. It is basically a JavaScript that runs in the background. It cannot access the DOM directly, okay? It is also a programmable network proxy, which means that you can control every request from the user browser to the web server. You can only register a service worker using HTTPS. And of course, if you're on development node, you can use localhost on HTTP as well. You can handle this kind of three events, which are fetch, sync, and push. So we'll have a look what those are. So the service workers allowed to implement push notification on your website. So for example, when you access a website and it allows you, when they ask you, for example, do you want to allow this website to give notification? So this is typically what the service worker push notification is. It has some offline functionality. It allows some kind of caching using this programmable network proxy, which we will cover later in the demo. It also has this functionality of background synchronization. What it means is if a user is submitting a form on your website and for any reason he loses internet access, the service worker is able to catch the post of the form, and as soon as the user goes back online, the post will be performed on the remote web server. So caching functionality is done with this onFetch event, we will cover later in the demo. So this is the way to register a service worker. So you will have a JavaScript in your page that will check if the service worker object is supported by the browser. And if yes, you can point to service worker JavaScript file within your domain. So as I say, it's a separate JavaScript file, same marriage origin policy applies. And an interesting thing is you can also register a service worker through a callback parameter of a JSONP endpoint. So this is a typical example of a content of a service worker. So you could have an event listener of the fetch event, and the fetch event, you can access this kind of method. So you can check if it's a get or post method. You can check the URL, of course. You can check if it's a F5 reload of the page or not. And so this will give control of, as I said, so this will be the programmable proxy I mentioned before. So you can control what to do with the request made from the browser to the remote web server. So everyone knows what cross-site scripting is. It aims to execute JavaScript on a victim browser. Is typically due to the lack of HTML escaping. So to recap, JSONP takes a callback parameter, a service worker allowed to register an on-fetch event, and it can be registered through a JSONP callback endpoint. And the aim of this attack is to exploit an existing cross-site scripting vulnerability on a website to obtain a persistent cross-site scripting, and now we will see how this works. So this demo currently only works on Chrome. So this is a fairly sophisticated demo. It has a JSONP which takes a callback parameter and just return whatever you specify in the callback. It takes a name with a user parameter which has a cross-site scripting, reflected cross-site scripting vulnerability in this case. So for this demo, I'm having a Beef project running locally on port 4000. So the aim is to get persistent hook into Beef using all of these JSONP callback endpoint plus on-fetch event of a service worker. So the malicious cross-site scripting payload we will put in this demo will look like this. So we will try to register a service worker through a callback endpoint, through a callback parameter of a JSONP endpoint. We will register the on-fetch event, and we will handle the event. So every time a browser will make a new request on this domain, we can control, let's say, if a request does not point to our local Beef in this example, we will return a script tag that will hook the browser on our Beef control, right? Everything else will kind of let browser perform the request against the original endpoint web server. So we'll try to run a quick demo now, if it works, hopefully. So this is a simple demo. So as I say, I have run this stupid application running on localhost port 9000, which take a user parameter, which is vulnerable to cross-site scripting, right? So we try to take our payload, okay? We'll check it in here, which is all well encoded and stuff. So for the first time, of course, we will not see, the only thing we'll see is, so after we register the service worker, every time we go back to this localhost 9000 domain, what we'll see in this case is would just be a script tag hooking into our Beef, right? So let's try to take the application server down. So let's say the remote application server is down. This will still work because everything is controlled within the service worker locally on the browser, right? So the browser, the victim will end up being hooked on Beef. So let's talk about mitigation, of course. Simplest mitigation is do not have cross-site scripting in the first place, which is fair enough. Interesting, I've done some research about like real JSONP endpoint in real website, and most of them do not filter callback parameter of the JSONP, which means is they do not whitelist, they do not allow only letters, number, underscore character, which should be the case. You should not be able to really need any other character as a callback parameter. Another mitigation is, of course, content secret policy, which you probably, as you know, you can disallow inline JavaScript to run in a web page. Otherwise, no. So thinking about this kind of attack, if you think about for a dynamic website, let's say a news website, you could programmatically take the snapshot of the current HTML, put it in this attack vector, and put the hook of the Beef at the end, right? What it means is the user will always see the exact same news over and over again, which is an indication of something weird going on. This is not really the case for single-page application, where typically the HTML and JavaScript is static, and all the dynamic content is retrieved by JavaScript after all the content is loaded. One note is Chrome allows to inspect both current registered service worker. So this is what it typically looks like. For example, for Twitter, it's telling me that current service worker register is activated, is not currently running, and it's telling me the URL of the service worker. Service workers can be dynamically unregistered as well. In a case that this attack is performed, it will not be much use because you will not be able to retrieve the new the new HTML actually from the web server once the service worker is actually taking over all your requests, right? So as part of this kind of little research I performed, a few days ago I wrote a beef module, which has been integrated literally 3 days ago, so which kind of automate this kind of attack for you. So if you grab today or anytime soon the latest beef head on Git, you will get this kind of a persisted module as part of the project. So yeah, this is pretty much it. So hope you enjoyed it.